Welcome to another session of Learning Together in Math. We have had 3 sessions before this. This is our 4th, and I'm so glad, so delighted for this privilege to share something with you that has been very important to a lot of students over the years. It has to do with negative and positive numbers. You'd be amazed to know that just what appears to be simple creates so much potential for error. And so many students have had difficulties juggling their negatives and their positives. So because we're laying a foundation, today I will just continue to add to that foundation another very important part of understanding the basics of mathematics. So today we'll start with adding positive and negative numbers. Again, I apologize if it appears simple to you, but I promise you that there are some students who really, really need this instruction. So bear with me. So to start, I would like to start with adding positive numbers. I'm sure if I was to ask you, what is 4 plus 3? None of you would have any problem with adding those 2 numbers together. You say 4 plus 3 is 7. For the purpose of our conversation having to do with positives and negatives, sometimes you might see your numbers put in parentheses with your operation in the middle. So it's saying we're adding this quantity to that quantity, and it so happened that because there's no sign, if the sign is not presented, then it is always known to be positive in math world. So 4 plus 3, even if they're in parentheses, it does not make a difference. It's the same as just 4 plus 3. Not a problem at all. So what do we have? We have 4 positives and we have 3 positives. Put them together, we end up with 7 positives. Notice I did not put the positive sign in front of the 7 because it's not necessary. However, if I did write positive 7, it is the same thing. It's just that everyone in math world know that 7 without the sign is positive 7. Let's try another one. If I gave you 6 plus negative 4, 6 plus negative 4, we're adding, but this time we're adding a positive number to a negative number. And I want you to just pay attention right here. If you notice, the positive number is 6, the negative number is 4. So this is a smaller number of negatives compared to a larger number of positives. So overall, the result is positive because you have more positive than negative. It's important to remember that negatives and positives cancel each other when we're doing addition. So in this case, because the positives are greater, then your result has to be a positive number. And it is what is left over after we use this to cancel 4 of these, so we're left with positive 2. Again, we're adding positive 6 to negative 4. There are more positives than negatives, so therefore the result is positive. Let's flip the switch and see what happens. Suppose I gave you, say, 5 plus negative 8. It's always a good practice to separate your signs so it's not confusing. So now in this case, we have more negatives than positives. And here we understand that every negative cancels a positive. So after we have used up 5 of these negatives to cancel these 5 positives, what is left over? What is the resultant? And we realize that in this case, there are 3 negatives left over. So the result would be -3. Again, 8 negatives, 5 positives. So overall, 3 negatives. Let's try another example. So what happens if we're adding and we have 4 negatives plus 3 negatives? Again, please understand that putting the parentheses here is not necessary, but it does make a difference. It doesn't spoil the math. It doesn't change the values or the operation. So we have 4 negatives and 3 more negatives. Let me say it again. It's 4 negatives and 3 more negatives. So what's the total? What's the overall result? The real answer, the correct answer is -7. So you had 4 before, and now you have 3 more. So now you have a total of 7. 4 before and 3 more gives you a total of 7. Okay? So, what can I use to explain this? You could think of it like this. If I borrowed $4 from you in the morning, and lunchtime, the word plus means and then lunchtime I came back and borrowed $3 from you again, how much do I owe you? Well, if I owe you 4 and now I owe you 3 more, then I owe you a total of 7. So I like to use that idea of borrowing for the negative. Or you could use your account. If you withdrew $4 from your account and you go back and you took out $3 more from your account, how much have you taken out altogether? What's the total withdrawal that you have made? It's a total of 4 and 7 and 3 make a total of 7. Another example that is used to illustrate and to explain positives and negatives is the use of a number line. Where if this is 0 and going this way is positive, and going this way is negative to the left. This is 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, -6, -7, -8. One way to explain this is 4 negatives. When it's positive, it means you're going forward. So positive, you concentrate on going forward. Negative, you think of going backwards. So 4 negatives mean that from 0, that's your neutral, that's your starting point. You went back 1, 2, 3, 4. So you're at -4. And you go back further, 3 more negatives. So it's 1, 2, 3. That takes you to a total of 7 backwards, -7. So that's another way to explain negatives. Backwards, and same as withdrawals. You withdrew 4 and then you withdrew 3. You now have withdrawn a total of 7. Okay, sounds very simplistic, but truthfully, I've seen students mess this up over and over. So let's look at another example. So if I had, say, -5 plus 8 minus, no minus, sorry, plus -4. What is that equal to? Interesting. So we have 5 negatives and 8 positives. So if you combine these two, then it means that we now have three positives plus -4. And then we have 3 positives and 4 negatives. So these 4 will cancel 3 of these and 1 left over. So the answer is -1. And that will be the final answer. When you put all these together, you have a total of 9 negatives. 9 negatives, 8 positives, so an overall 1 negative. So that takes care of addition. Let's try and look at some subtraction and see what happens. Yes, so now the fun begins. So if I was to ask you what is 10 take away 6? Again, I could put the numbers together like this. 10 take away 6. This is 10, this is 6, and this is the operation, subtraction. So it's 10 positive take away 6 positive. So you have 10 items and you're taking away 6 of them, so you're left with 4. Nobody has a problem with that because you don't even need the parentheses. Nobody would have a problem seeing that. 10 take away 6. You're taking away a smaller number from a larger number. Not a problem. Nobody has a problem with that. Very, very easy to understand. Let's see what happens when you change that up. We said 10 take away 6 equal to 4. Suppose it was the other way around. Suppose it was 6 take away 10. So you have 6 items and you're taking away 10. And somebody would say, but that never happens. Well, we do it all the time with our spending. We have $6, but we spend $10. So we end up what? We end up owing $4. And that's why beautiful credit cards come into play, or lines of credit. Or the bank says, insufficient funds. You have spent more than you own, or more than you have. So what are we doing? We're taking away a larger number from a smaller number. When I was in primary school and they tried to do this, they would say, we can't. And that would be the end of the story. But as we got older, they say, wait a minute. It actually happens in real world. As a matter of fact, business people will tell you that they use what is called an overdraft. They can take more money than they actually have. It so happens that if you do that, you owe somebody the difference, okay? So that's where credit, the word credit comes into play. You have spent more than you have. So in this case, the answer is -4. Whenever you're dealing with money, a negative sign is not a good sign. Whenever dealing with a bank account, a negative sign is not a good sign. It means that you are short, you owe. And again, it makes sense. You have 6, but you want to take away 10. So it has to be a negative. It can't be a positive outcome. It has to be a negative outcome. You're taking away more than what you have. So that's why you end up with a negative. So far, so good. If you're subtracting a positive from a positive, no problem. You're subtracting a positive from a positive, no problem. It's all happening that because this is bigger than this, the result is a negative number. So what happens if the signs are different? Suppose I have -6 take away 5. Wow. What is that equal to? So we are subtracting 6, and then we're going to continue and also subtract 5. So what's the total? What's the overall result? I would suggest you think of it like this. You borrow 6, or you take your bank account, you withdrew $6, and then you withdrew $5. So how much have you overall taken out? How much have you withdrawn total? Another way to look at it is you take 6 steps backwards and then you take 5 steps backwards. So what is the overall effect? You have actually taken 11 steps backward, or you have taken $11 out of your account. You subtract 6 and then you subtract 5. So you have subtracted a total of 11. And that's how we do that. Okay? So what happens now if we have, say, -6 take away -4? Now it gets tricky. Now it gets interesting. Key thing to remember is this. Whenever you have a negative sign in front of another sign, it means that it's doing the opposite. So -4 is saying, what is the opposite of -4? And the answer truly is +4. In math, I would say if you're minus, it's a plus. But I'm trying to show you the reasoning behind it. If I ask you, what is the opposite of 6? The answer is -6. What's the opposite of 1? It is -1. So what's the opposite of -1? It has to be 1. What's the opposite of -6? It has to be 6. So whenever you think of opposites in math, it's the change of sign. So the opposite of 100 is -100. The opposite of 50 is -50. So therefore, the opposite of -20 has to be 20. So the final answer for this is going to be -6 + 4, because this is the opposite of -4. -4, opposite of that is 4, so the final result is -2. So we have -6 take away -4 becomes -6 + 4. Minus gives you a plus. And -6 + 4, you have 6 negatives, 4 positives. So you end up with an overall of 2 negatives. Let's try another one. If I gave you -5 minus -9. So -5 minus -9. This minus here means the opposite of what's here, the opposite. So it's going to be -5 + 9. And that, of course, is equal to +4. So what have we done? We have actually changed the subtraction to an addition. If you have a minus, this means the opposite of this. So therefore it becomes +9. So if you're going back, so it's the reverse of going backwards, it's going forward. Okay? Another one. So if I gave you 6 take away -4. So 6 minus -4, by now you realize it's going to be 6 + 4. Minus, the opposite of -4 is +4, gives us 10. Again, just reasoning it out. You're going 6 forward, and then you're doing the opposite of going 4 backwards. So it's going 4 forward. So 6 forward, then 4 forward, 10 forward. Total of 10. Okay? So what about this one? What about 0 take away -6? So that would be equal to 0 plus 6. And that gives us 6. So now we have dealt with addition of negatives and positives, subtraction of negatives and positives. Let's go to multiplication. I will take this time right now to tell you that multiplication and division follow the same rules when dealing with negatives and positives. So, for multiplication, if we had, say, 2 times 5, again, it's positive 2 times positive 5. We all know that that's equal to 10. Of course, I could have written it as 2 times 5, and that's 10. Does make a difference. The sign is positive, so everything is fine. However, if we had negative 2 times 5, it means that we are having negative 2 5 times. Negative 2 5 times. It's actually equal to negative 10. And I'll show you using smaller numbers. I'll show you. I'm just trying my best to make it make sense so that you don't have to memorize. You can actually think it through and then make it start to make sense. Because once you can think it through, it becomes easier. But if you have to memorize it, it's always going to be a challenge. Okay? If I ask you what is 2 plus 2 plus 2, you know that's equal to 6. We all know that. But couldn't we say, how many twos do we have? We have 1, 2, 3. 3 twos. So we could actually say it's 3 times 2. We could say, oh, it's 3 of them, so it's 3 times 2. Yes? Watch this. So if I say to you, negative 2 plus negative 2 plus negative 2 plus negative 2. 1, 2, 3, 4 plus negative 2. How many negatives do I have? I have 2 negatives, 2 negatives, 2 negatives, so I have a total of 10 negatives. But don't you agree that I have negative 2 5 times? So isn't that the same as 5 times negative 2? It's 5 of them, and when you add the 5 things, we end up with negative 2 and negative 2, and it's like go 2 backwards, 2 backwards, 2 backwards, 2 backwards, 2 backwards, total of 10 backwards, or borrow 2, and then borrow 2, and then borrow 2, and then, so we end up borrowing a total of 10. So we see that it's the same as negative 10. So what do we notice? If we multiply a positive times a negative, we're getting a negative result. Let's try another one. What is, so if I gave negative 3 times, sorry, plus negative 3 plus negative 3 plus negative 3. So we have negative 3 4 times. So instead of writing it 4 times, I could say, oh, it's 4 times negative 3. Now, if I just add these numbers together, 3 negatives, and 3 negatives, and 3 negatives, and 3 negatives, everyone can see that's total of negative 12. Here, 4 times negative 3, I'm saying to you that once the signs are different, the result will always be negative. Let me say that again. If you're multiplying two things and the signs are different, the answer will always be negative. And this is the proof right here. Negative 3 plus negative 3 plus negative 3 plus negative 3 is the same as 4 times negative 3. And we know that if we add these negatives together, we get a total of negative 12. So they tie together, they come right back to make sense. Okay? So from this point forward, anytime you multiply two numbers and the signs are different, your result is always negative. The converse is true. Okay? If the signs are the same, the answer is always positive. And remember I said to you that the rules for multiplication are the same as the rules for division when dealing with negatives and positives. So let's try another question. So 4 times negative 2 is equal to negative 8. Negative 4 times 2 is equal to, so we're multiplying negative 4 and multiplying times 2. By the way, whenever you have two sets of parentheses and there's no sign between them, it means that we are multiplying. In math world, it is understood that if there's no sign, whether it's a plus, a minus, a subtraction, or a multiplication, if no sign is given, as long as you have two set of parentheses beside each other, it is multiplication. So again, this will be the same as negative 8. It's 2 times 4 is 8. The signs are different, so it's negative 8. Okay? And then finally, if we have negative 4 times negative 2, it now means that we are working with negatives and negatives. Okay? So there are different ways we could do it. We could say, okay, we could say since it is negative 4 times negative 2, we could say it is the opposite of 4 times negative 2. Well, 4 times negative 2 is negative 8, and the opposite means that it is positive 8. So that's an explanation you could use. That if you treat the negative last, it's that 4 times negative 2 is negative 8. And the opposite sign would be positive 8. So there it is. Okay? Just to summarize, let's summarize it right now. So if we get 2 times 5, it is 10. Positive times positive gives us positive. If I have negative 2 times 5, the result is negative 10. It is a negative times a positive. If I have 2 times negative 5, it's always good to put the negative sign in parentheses so there's no confusion. We end up with some positive times a negative, it is negative 10. And finally, if I have negative 2 times negative 5, of course I can put these in parentheses if I want. I don't have to. If I want, I can. So now we're doing a negative times a negative. The answer is positive. So there it is. Positive times positive, positive. Negative times positive, negative. Positive times negative, negative. The signs are different. And here, signs are the same, positive. If you remember that, you will not go wrong. Okay? And just for the purpose of completion, I will do the division. So if we had 12 divided by 6, 12 divided by 6, so it is positive 12 divided by positive 6. We all know it is 2. And based on the principle that I've shared with you, if one of them was negative, so negative 12 divided by 6, you have one negative, one positive, the answer is negative 2. And if I have 12 divided by negative 6, as long as the signs are different, that's all you need to know, that the signs are different, then the result is going to be negative. And then the last situation is if you have negative 12 divided by negative 6. Once the signs are the same, the result is positive. So there you have it. When multiplying numbers or expressions, if the signs are different, the result is negative. When multiplying expressions and the signs are the same, the result is positive. When dividing, if the signs are different, the result is negative. If the signs are the same, the result is positive. So now that takes us into order of operations. So what are the operations we're talking about? Operations. So we have parentheses, we have exponents, we have multiplication, and we have division. We have addition, and then we have subtraction. Okay, so these are, okay, I should have put this here, but these are the basic operations that we use in math. Parentheses, we use exponents, we use division, we use multiplication, we use addition, we use subtraction. So the question is, if you have one question or one expression that involves a mixture or a selection of these operations, it is important that we know which operation goes first or which one has priority, because if we don't know the priority, we will end up with the wrong value. So it's important to understand who is on first, okay? And there is a mnemonic that we use to remember this, and I'll show it to you. You know, in life, we often use different things to remember different things. So this is one that is often used. PEMDAS. Please excuse my dear aunt. Sorry. Please excuse my dear Aunt Sally. This is something people use to remember. Parentheses go first, exponents go second, multiplication and division. Truthfully, multiplication and division, they are equal in priority. It doesn't matter which one you do first. it will give you the same result. And addition and subtraction, it doesn't matter, they're equal. So these two are equal, these two are equal. So parentheses, you always do what's inside your parentheses first. Then if there is an exponent, then you take care of your exponent. And then if you have a multiplication or division, you do these. And then if you have an addition and subtraction, you do those. For it to make sense, I need to do some examples. Okay? So you might see this expression, evaluate. Say 2 times 6 minus 4, say no, 6 minus 3. Suppose I gave you that. What is that equal to? According to PEMDAS, this says whatever is in the parentheses, you must do that first. So then this must be equal to the 2 stays. Remember, this 2 is multiplication. You're doing 2 times. What is inside the parentheses? 6 minus 3 gives us 3. So we have done the first step. We have taken care of the parentheses. 6 minus 3 gives us 3. Then what does it say? So we can check. Exponent, r is to the power 3. So we need to do that next. So it's going to be equal to 2 times. What is 3 to the power 3? It means 3 times 3 times 3. You multiply 3 times itself 3 times, and that's 27. So we have taken care of the exponent. So now we have 2 operations left. We have subtraction and we have multiplication. So the question is, what do you do first? Do you do the subtraction or do you do the multiplication? Well, PEMDAS says that multiplication comes before the subtraction. You have to do the multiplication first. So therefore it becomes 54 minus 1 gives us 53. Again, by following the correct order, you will end up with the right answer. If you do not do the correct order, you will have a problem. Let's try another example. How about this one? 8 minus 3 times 5 minus 1. Okay, so this is number 2. I will tell you that over the years of teaching, I've seen students say, oh, 8 take away 3 gives me 5. And they do this first, 8 take away 3. But when you do that, you're breaking all the rules. In other words, you're almost jumping to the last priority, the lowest priority, and taking care of that first. And that's a no-no. This, you don't even do this yet. This can be done later. This has to be done later. You have to go and look at what you have. You have to look at the complete picture to decide what goes first. So in this case, it's going to be 8 minus 3 times parentheses. We have parentheses, so we have to take care of those first. 5 take away 1 is 4. Now we go again, is 8 minus 3 times. Next, so we have taken care of our parentheses. And I say, there's an exponent. So therefore I have to take care of the exponent next. And the exponent says 4 to the 2nd power, and that's 16. And now we say, okay, what do we have left? We have a subtraction, we have a multiplication, and we have an addition. Again, we have subtraction, multiplication, and addition. Of the order that's here, we have subtraction, addition, and multiplication. So it tells me that multiplication is next. So I need to do the multiplication next. So I go 8 minus 3 times 16, 48, plus 20. And as I said to you before, the addition and the subtraction, the order is not important. You can do either one. You will still get the same answer. Okay? So what I'm going to do for you is I'm going to do it both ways and show you that the answer remains the same. So let's go. If I do 8, take away 48, I get negative 40. I'm taking away a larger number from a smaller number, I get a negative answer. And it's plus 20, and that gives me negative 40, positive 20. When I put these together, I end up with an overall negative 20. Because 20 of these cancel 20 of these, I'm still left with 20 negatives. Suppose I've done it the other way. Suppose I've done the addition first. 8 plus 20 is 28. Take away 48. Look what I did. I said, let me add the 20. 20 plus 8 is 28. 28, take away 48. Again, I'm taking away a larger number from a smaller number, and that's a negative. And the difference between 28 and 48 is 20. Of course, there's a third way I could have done it. I could have said negative 48 plus 20 gives me negative 28. And 8 take away 28 is negative 20. Positive, adding and subtracting, same priority, does make a difference. Let's try another one. Okay, so number 3. So we're evaluating, we're trying to find the value of. So in this case, we're going to go 4 times 5 take away 3 minus 2 times 4 take away 7 divided by ooh, this is ugly. So 4 times 5 minus 3 minus 2 times 4 take away 7 all over negative 8 minus 6 squared. Quite a few things involved here. Quite a few operations. But the key step to doing this is, and I use this example when I'm teaching, I say when you're served a plate of food, you don't just take the plate and gulp it down. You go 1 serving at a time, 1 serving at a time until you're finished. It's the same thing here. We call it in math, we call it systematic processing. Step-by-step processing. You do it step by step. Follow the sequence, follow the operation, follow the order, the preference, the priority, and you will get there. So, and another way to say it is the longest journey starts with the first step. So we look at it and we say, okay, what do we do? Well, we know the order says, parentheses, please excuse my dear Aunt Sally. So what we do know is that whatever is on top must be simplified. Whatever is on bottom must be simplified. And then we need to divide what is on top by what is below. Okay? So let's simplify the top. So it's going to be 4 times 5 minus 3. We have to do the parentheses. We end up with 2. Minus 2 times 4 take away 7 is negative 3. We're taking away a larger number from a smaller number. 4 take away 7, -3. And then at the bottom, what do we have? We have the negative of 8 take away 6 is 2 squared. We're getting there, we're getting somewhere. So what does that become? So we have done the parentheses. And now for the top, the exponent at the bottom doesn't affect the top. So I can continue working on the top, and I can also work on the bottom, and then I put the two together. So what do we have? 4 times 2 is 8. And -2 times -3 is +6. Somebody's gonna say to me, oh, wait a minute. Isn't it -2 times -3? Okay. What is 2 times -3? It's -6. But what is the opposite of that? What is the negative of that? +6. So let's go back again now, because I did a fast one on you. -2 times -3. And negative times a negative is positive. Another way you could do the same process, and you say, okay, think of this as a subtraction. You're going to subtract 2 times -3. 2 times -3 is -6. If you subtract a -6, it's minus minus becomes a plus. For the bottom, you have the minus sign and you have the exponent. The exponent comes before the negative sign. The exponent comes next. So we go 2 squared is 4. So this is going to give us -4 on the bottom. 2 squared is 4 and it's -4. 8 plus 6 is 14. And when you simplify that, it becomes -7 over 2. Please understand that a positive divided by a negative is a negative. The two signs are different, so the result is a negative. And the preferred answer should have the negative sign on top. That's a preferred answer. So we simplify the fraction, which we discussed in a previous lesson, that fractions can be represented in different forms. It's just that you can reduce them to their simplest form. And 14 over 4, we agreed, is the same as 7 over 2. And we got that by dividing the top and the bottom by 2. Okay? Let's try another one. So we need to evaluate this one. Oh boy. Oh boy, he's losing his mind now. He's going crazy. What is he doing? I'm glad you asked. So let's go. Again, what is the rule? We go step by step. And we discussed that as we call it systematic processing. Systematic, step by step, just following the rules. Okay, so we're going to simplify the top, simplify the bottom, and then put it all together. Okay, so -2 to the power 4. Wow. Let's do a sidebar. Let's work it out to the side. So it's -2 times -2 times -2 times -2. So it's -2 times itself 4 times. That's what the power 4 means. You're multiplying it by itself 4 times. Well, let's reason. Negative 2 times negative 2, what is that? That's 4. Negative 2 times negative 2, that's 4. So in truth and in fact, negative 2 to the power of 4 is really 4 times 4, which is 16. I like to use sidebar, so you just isolate the thought process and you can concentrate on one part at a time so that you don't get confused. So we just went ahead and discovered that negative 2 to the power of 4 is just 16. That's another way of writing 16. How did we get the 16? We wrote negative 2 4 times. Negative 2 times negative 2, positive 4. Negative 2 times negative 2, positive 4. So now it's 4 times 4, 16. So I can go ahead and write 16 here for this part, plus 3, and I have to work out this first. So that's going to be negative 2 squared. 5 take away 7 is negative 2. And it says that I need to raise it to the power 2. Go to the bottom. So it's negative 4. We have to work on the parentheses first. It's negative 1. And then it's to the power of 3. We're getting somewhere. We're getting somewhere. I need the space to write, so I'm going to erase this. Okay? Equal 16 negative 2 to the power 2. It's negative 2 times negative 2. So negative 2 to the power of 2 equal to negative 2 times negative 2. If you need to do a sidebar to make sure that you don't make a mistake, do it. It's your paper. Do it. So that gives me 4. So I know that this is 4, and I'm going to multiply by 3. So it's 16 plus 3 times 4. All over negative 4 times. What is negative 1 times? What is negative 1 to the power 3? So it's going to be, I think I can erase this now. Negative 1 to the power of 3 is equal to negative 1 times negative 1 times negative 1. Later on, we'll do a simple way to get it, but I just want to illustrate the process. Negative 1 times negative 1 is 1 times negative 1. So now we have 1 positive times 1 negative. And if the signs are different, the answer is negative 1. Let me repeat. Negative 1 to the power 3 is negative 1 times negative 1 times negative 1. When I multiply these two, I get positive 1. But I still have another negative 1 here. So 1 times negative 1. The signs are different. So my answer is negative 1. So I can go ahead and put negative 1 here. So what do I end up with? 3 times 4 is 12. So now we have 16 plus 12 over negative 4 times negative 1. A negative times a negative is positive. So that gives me 4. And 16 plus 12 is 28. 16 plus 12 is 28. So the answer is going to be 28 divided by 4. And that works out to the beautiful number of 7. How cool is that? That will be the final result. Okay? Was this helpful? Did you find this to be useful? As I close, I want to share one last example to give you an idea, give you a sneak preview as to how this becomes useful as we go further in math. I'm going to give you one last example. In math world, instead of evaluate, you might see something that says simplify. And just to give you, again, it's a sneak preview, it's just of what is to come. If you were to see something like this, 2 times 3x plus 5y minus 4 times 5x minus 2y. And they ask you to simplify that. Then you'd say it's equal to 2 times 3x is 6x. 2 times 5y, it's 10y. Now, negative 4 times 5x is negative 20x. Negative 4 times positive 2y is positive 8y. And then, now you need to put like terms together. So 6x take away 20x gives you negative 14x. Look at it. A 6 take away 20. A small number take away a bigger number gives you a negative result. Then 10y plus 8y gives me 18y. So this is just a sneak preview as we transition over into algebra. Again, we're just laying foundation, but I'm just sort of teasing you as to where the train is going. Eventually, we'll get there. Okay? Well, this brings us to the end of our session for today. I hope you like the journey. I try to be as painless as possible, but believe me, even though these skills might appear on the surface to be simplistic, they have far-reaching effect on accuracy. And many people make mistakes with their negatives and their positives. Many students make mistakes as to which operation should go first. I do hope that as a result of what we have done this evening, that you're in a better position to master your negatives and your positives, along with your order of operations. On behalf of the Ruseas family, the Ruseas Old Student Association, I thank you for spending this time with us, and I look forward to future episodes with you. Have a great evening.